Right, hello. I want to talk briefly today about, or in this lesson, about averages. Now, in general, when you're speaking about averages in mathematics, then the use of the word average probably indicate that what you're saying is wrong or lead to a loss of marks, because there's no such thing as the average in mathematics. There's several different ways of computing it. There's the mean, the median, and the mode. Now, I don't know, if I have a set of data, just make this up. The mean, that's the more sort of familiar form of the average, if you like, where you just add those figures up and then divide here through by 7. Now, an alternative way is the median. And the median I can read off straight from this because I've laid the data in size order. The median is just the middle element when they are all arrayed in order of size. So I've got 7 data points here, and that's the middle one, the fourth. So that is the median. And there is another one called the mode, which is normally sort of relegated to sort of third place. The mode is the figure that occurs most often. So, I mean, in this one here, the mode here would be 1. And you might think that might be fairly useless when looking at this data as a whole. But, I mean, the things like manufacturers of clothing and shoes and so on would have an interest in what the mode is in their particular field. Now, the thing is, now in GCSE, there used to be coursework in GCSE, so the understanding of statistics tended to be a bit more wider than it is nowadays. That would previously have involved sort of quite in-depth discussion of the relative pluses and minuses of these different averages. But generally, just to quote one obvious difference, well, you see, the thing with the mean, how can I say this? With the mean, if there's any errors in any individual figure, then this could really skew the data. And I can imagine situations like that where it would skew the mean data but have little effect on the median. Again, I'd have to invent figures here, but I mean, say there was a test here that the real figure should have been 8, but someone has made a total mess up and reported it as 15. And down here, there's a figure of that should be, say, 2, and someone's made a mess up and described it as 1 or something like that. Now, you can see that the mean, if you were to calculate the mean, these errors here that people have made would skew the mean. But when you look at the median will stay the same. So that's one possible feature of the difference. I mean, as I say, nowadays it doesn't really go into it as much as it used to, but I mean, it's useful to realise this in real life as well. I mean, I think at the time of speaking, I think the difference between the mean average income in Britain and the median average income is something like £6,000. But you can imagine that when the average income is reported in the news and so on, they very, very rarely mention the words mean and median. They just use the words average. So, you know, without knowing whether that's the mean or the median, it's not particularly useful, particularly if different people are using different measures of what they class as the average. So that's just something to bear in mind. Now, there's another reason why the average, or whichever average you're taking, there's another reason why the average is of limited meaning by itself. I mean, you've got something like this. This is a pack of cereal. Now, if you see down here, this is supposed to be 550 grams. Now what this little E here is, this E is telling you that this is an average. And for one, I mean, to a certain extent, it would be totally impossible. You know, you can imagine the way that this food is produced. It would be totally impossible to get slap bang on 550 grams in this packet. So there's going to be a slight variation purely due to the production processes anyway. So that's allowed for in this average. But I think there's more information here that contained in this little E here, or a bit more information that's required, and that is basically the deviation. I mean, although there's an average of 550 grams, if I go in 1 week and buy this packet and it's only got 450 grams in, and then I go in the week after and I buy the same packet and it's got 650 grams in, then that is consistent with an average of 550 grams. So you need a bit more information rather than just the average. You need some idea of the deviation. And again, going back to what I said before about coursework, this was more you know, a bit more emphasis was given on this during the coursework to give you a bit of a clue as to deviation from an average. So, for example, you might get something, a mention of a normal distribution. A normal distribution looks something like this when you graph it, where that would be the average there. So that's giving you a bit of a clue. Well, just bear with me. Yeah, I mean, the normal distribution is a sort of an idealized or a theoretical distribution which some real-life situations are proposed to follow. I mean, this, you see this quite typically in things like IQ tests and so on, where this might be 100. In an IQ test, that might be 100, and very intelligent people might be off here and so on. But you can gauge from the nature of this normal distribution, the sort of the percentage probability that some people are going to be off here and so on. And you can see that very, very wide deviations are going to have a very, very low probability. So although I don't know what average they were using on that cereal pack, I would imagine that they're using a normal distribution here, which is the normal distribution has the unique, or not the unique, but it has the property that the mean and the median are identical. But in general, for anything, that you might expect the mean and the median to be different. But you can see that if that cereal pack, if the weight of that cereal pack is following a normal distribution, then there is a certain probability that it is, the deviation widely for 550 grams is going to be quite low. It's going to be off here. So you've got some idea that when you buy a 550 gram packet, you've got a very good probability that it's not going to deviate too much from 550 grams. Now, one thing that you do come across in GCSE still is this idea of I don't know. Can you see that? Probably this is the courtesy of Statistics Canada, but they're giving a box plot here. Hopefully you can see that okay. Now this works on displaying data using the median. Okay, so if I just go back to the median for a moment, this median splits the data into equal number of data pieces. Okay, so if I choose that is, ignore these this for the moment. This 6 is the median of those pieces of data here, and that splits it up into two groups. That's got 3 items, and that's got 3 items. Okay, so that's the effect of the data. It's going to split it up into 2 groups of an equal number of data items in each. Perhaps I should say here also that if the number of data items was even, then the median would be chosen by taking the 2 central items and finding the average or the median point of those two data items. So you'd still have a situation where the median would split the data into two separate pieces, two separate groups, both with equal number of members. Now, I could extend that. This data is a bit too low to show this, but you could extend that idea to, I could show it here actually. If I took that data, I could apply the same sort of idea and choose what's called the quartile. So I've taken that data and taken the middle item, and that has actually given me what's called the quartile. And I can do the same here. That means the quartile. Because I've only got 7 items here, it's a bit meaningless to have quartiles and so on. But you can see the general idea. So I've got the median into 2 groups of equal size, take the quartiles, which then produce, in their own little way, 2 groups of equal size, which together produces 4 separate groups, and each group has the same number of data items in it. And this is what this is showing here. There would be a scale down here of numerical scale down here normally, and you've got the median. Now what you've got here, you've got the quartile, and they've put that down in a little box. So that, looking at that gives you a clue as to the average and how widely the data is spread about the average. You know that half the items in this group are contained within this box. And these whiskers, they go up to the absolute minimum data and the absolute maximum data. So, of whatever group you had, a quarter of the group will be in here, a quarter of the group will be in here, a quarter of the group will be in here, and the quarter of the number of data items will be in here as well. And to me, that's fairly straightforward. I mean, it's good visual image of not just the average, but how much the data is spread around the average as well. Okay, so I mean, as I say, to me that's fairly straightforward. But the reason I'm really putting stress on it is that I know from experience that A-level students have difficulty with this for some reason. I don't know why, but so it's for that reason I'm just putting a bit of emphasis on it here. Okay, hopefully you can see that. It's probably slightly out of focus, but hopefully you can see the general idea. Anyway, that's all I need to say on that particular topic from now, and so cheers for now.